Hey, Grade 5. I am back with a shiny new haircut, that's kind of my old haircut, to show you guys a science experiment that I've been planning on doing for a while and I thought you might be interested to see. Now, in this one, I'm going to show you guys how to make homemade boba. If you don't know what that is, it's those little balls of juice or sweet flavor that you'd find at the bottom of a bubble tea. They are really good, and you can make them at home out of a few cooking chemicals and whatever kind of drink you'd like to use, whatever liquid you'd like to use for them. I'm going to make root beer ones today so that you can see how it works. Now, this is a chemical reaction, which is why I'm filming it for you. I'm doing this as a chemistry experiment. It requires the separation of two molecules that I've pre-bought and recombining them into something new. Now, this is not the kind of reaction that you'd see with baking soda and vinegar, where something big and violent happens. Instead, we're going to see a chemical bond happen that forms a skin around the outside of the boba and keeps everything together. So what am I going to use for it? Well, I've got my materials laid out in front of me, and as I've tried to drill into you guys throughout our science times, listing your materials and exact amounts of them is important. So, what do I have? Well, here I have 250 milliliters of root beer. Now, I just made this myself in the soda stream about 5 minutes ago. It's nice, fresh root beer. This is 2 cups, or about 500 milliliters, of tap water. Just tap water, plain and simple, that's all. This is called a mortar and pestle. It's used for grinding things up, and you'll see why I'm going to need that in just a moment. Got a couple of things for stirring. I've got a 1 teaspoon measure here, because both of the chemicals that I need, I'm going to need 1 teaspoon of. And then I've got my chemicals. The reaction that we're going to see here is between these two chemicals. Sodium alginate. Now, sodium alginate, there it is a chemical that's derived from algae. It's honestly one of the things that makes algae so slimy. It's a pretty simple molecule, and it bonds very well with another molecule called calcium chloride. Now, calcium chloride is very common in cooking because it's used as a thickening agent. So it says on the label here, used for wine and beer making. It's also used if you're making cheeses or yogurts. Anytime you need to make something thicker, but don't want to introduce new flavors or weird new things to the mix, you can use calcium chlorate powder to do that. So what we're going to do today is we are going to take, here's our procedure, we are going to take 1 teaspoon of sodium alginate. We are going to mix it into our root beer. When that is finished, we are going to take 1 teaspoon of calcium chloride. We're going to grind that up in the mortar and pestle because it comes in little pellets and we want it to be a powder as best we can. So we're going to grind that into a powder and then mix it into our water. When that's finished, it's a pretty simple procedure to just drop the root beer with sodium alginate into the water with calcium chloride. Now, those two solutions are going to create something a little bit different, because when the calcium chloride and sodium alginate get near each other, those molecules are going to want to react to one another, and they're going to pull apart. They're going to separate from each other, but leave the root beer and the water intact. Now, around the outside, as they meet, as the sodium alginate is pulled to the outside, the sodium will be pulled all the way out, and just the alginate will stick to the outside of our drop of root beer. That will mix with the calcium from the calcium chloride. As those two bond, a little shell of calcium alginate, which is a flavorless, odorless, perfectly safe gel, will form around the outside of a ball of root beer, holding it together and making it into a little ball of root beer jelly. The sodium and chlorine from the calcium chloride and sodium alginate will then attach to one another again in the water and become sodium chloride, which is just salt. At the end of this, when the reaction is finished, we're going to have balls of root beer with shells of calcium alginate floating in a bowl of salt water. Let's get started with our first step. Step 1. Take 1 teaspoon of sodium alginate. Just a nice, fine white powder. Kind of looks like baking powder. See if I can get it on the camera. There she is. Sodium alginate mixed into root beer. Great. Now I've got a fork here. It actually said to use an immersion blender, but I'm just going to use a fork and give it as best a whisk as I can. Now you'll notice as I'm doing this, some of the carbon dioxide is starting to come out of the root beer. And I'm going to want to stir this a while. Alright, let that be a lesson to all of us. The instructions say blend, you blend. Don't mess around with a whisk if you need a blender. Okay, part 2. We're going to take a teaspoon of the calcium chloride. Now this you can see looks quite a bit different. As I get it out, you can see it's already heaping over the top of the spoon. Oop. It is noticeably larger white pellets. And we want it to dissolve quickly. So one way to do that is to spread the pellets into a powder. So we're going to put those pellets in our mortar and pestle. Well, in our mortar. The pestle is the stick that we grind it with. And we're going to grind them up. This could take a minute, but here we are. Crunch, crunch, crunch. All right. We have turned what was once a very large bunch of pellets into a very fine powder. We're going to mix that into our water. And give it a stir. We want it to dissolve as quickly as possible, but we need to keep the water cold. Now this does a much better job of dissolving than our friend sodium alginate, and in fact is nearly done already. You might notice the water's gotten a bit cloudy. There's still a little bit of pebbles on the bottom. We'll stir a little more, but it's pretty much done already. Now I do want to point out I am not wearing goggles, I am not wearing gloves. That is because these are all food grade chemicals. The worst I could do here would be if this is all stuff I could put into my body and eat. So I'm not too worried about getting it on my fingers or, it's not going to splash me in the eyes and cause any damage. I might need to rinse, but that's it. Now, we are going to need a spoon, which I forgot to get. This is just going to be for fishing out the boba when we're done. Here I have my root beer with the sodium alginate mixed into it. I have my water with the calcium chloride. And I'm going to start dropping root beer into the water. You can see as it hits, it starts to form little peas of root beer. I can do a bigger blob if I want. But really, after a few seconds, they're already ready to fish out. And I've got a lot more I could use. Let's grab one. Cold. A little balls of root beer. These are Boba. You can see I can squish them out. They're full of root beer, full of liquid on the inside. They are just little eggshells full of root beer. And they're quite tasty too. Now what am I going to do with these? Well, I'm going to make a bunch of them. And then I'm going to put them on some vanilla ice cream. Get all of that for later. Now, if you'll excuse me, I'm going to fish these out and get a bowl. You know, all the best homework is the kind you can eat. Now, make no mistake. If we were in school right now, we'd be sharing this treat together on a hot science class somewhere out in the field, probably. As it is, I hope that by sharing the recipe, you might get to make some of your very own ice cream boba combination. It's pretty good. All right, guys. That's it for today. I hope you enjoyed a little bit of bonus science. I'm going to finish this bowl of ice cream. Peace out.